On this Ram 1500 Classic with the 5.7 Hemi, P0521 points to an engine oil pressure sensor performance problem. In plain terms, the PCM is seeing oil pressure information that does not match what it expects for the operating condition. The MIL may be on, and depending on what is actually happening, the concern can be in the oil or mechanical side of the engine, the sensor circuit, the sensor itself, a connection issue, or possibly the PCM. We are going to work this like a sensor performance code. Confirm the code, rule out real oil and mechanical problems first, then simulate the sensor circuit and check the wiring before condemning a module. Start with the basic system checks, then reproduce the operating conditions for this code. This monitor runs with the engine running and engine speed above 1,150 RPM. The code sets when engine oil pressure is below the calibrated specification for more than 29.8 seconds with engine speed at or above 1,150 RPM. Test drive or operate the vehicle under those conditions. Then use the scan tool to read and record the codes. If P0521 is active or pending, continue with the oil and mechanical checks. If it is not active or pending, treat the problem as intermittent instead of forcing a hard fault path. Before chasing the electrical side, make sure the engine and lubrication system are not creating the pressure concern. Check for engine mechanical tolerances out of specification, engine oil pressure out of specification, low oil level, deteriorated or dirty oil, and oil contaminated with coolant or fuel. This step matters because skipping it can lead to a wrong diagnosis. If any of those conditions are found, repair as necessary. Then verify the repair and confirm the code stays gone. If none are found, move on to the EOP sensor operation check. Now check the engine oil pressure sensor circuit response. Keep the fan, belts, and pulleys in mind anytime the engine is operating. Do not stand in line with the fan, keep hands away from moving parts, and avoid loose clothing. Turn the ignition off and disconnect the EOP sensor harness connector. Turn the ignition on, monitor EOP sensor voltage with the scan tool, and connect a jumper between the K900 sensor ground circuit and the G6 EOP signal circuit. The EOP voltage should change from approximately 4.9 volts to less than 0.1 volt. If the voltage change is within that specification, verify good pin-to-terminal contact at the sensor and PCM connectors, remove the EOP sensor, and make sure the oil passage or port is not blocked. If no problem is found, the diagnostic path supports replacing the EOP sensor, then verifying the repair. If the voltage does not respond correctly, remove the jumper before continuing and go into circuit resistance testing. For the circuit checks, do not probe the PCM harness connectors. Probing those terminals can damage them and create a poor terminal-to-pin connection. Use the GPEC diagnostic adapter 10436. With the ignition off, disconnect the PCM-C2 harness connector and connect the adapter. Measure resistance in the G6 EOP signal circuit from the engine oil pressure sensor harness connector to the GPEC adapter. Resistance should be below 3.0 ohms. If it is below 3.0 ohms, continue to the 5-volt supply circuit. If it is not below 3.0 ohms, repair the G6 EOP signal circuit for an open or high resistance, then verify the repair. Next, measure resistance in the F855 5-volt supply circuit from the EOP sensor harness connector to the GPEC adapter. The specification is below 3.0 ohms. If the circuit is below 3.0 ohms, move to the sensor ground circuit. If it is not below 3.0 ohms, repair the F855 5-volt supply circuit for an open or high resistance, then verify the repair. Now measure resistance in the K900 sensor ground circuit from the EOP sensor harness connector to the GPEC adapter. Again, the resistance should be below 3.0 ohms. If it is not below 3.0 ohms, repair the K900 sensor ground circuit for an open or high resistance, then verify the repair. If it is below 3.0 0 ohms. The next move is connector and harness inspection. Disconnect all PCM harness connectors, any related inline harness connections if equipped, and the related component connectors. Inspect the harness connectors, component connectors, and both male and female terminals for poor installation, damaged locks, corrosion, water intrusion, weather seal damage if equipped, bent terminals, overheating from a poor connection, and terminals pushed back into the connector cavity. Also check for spread terminals and confirm proper terminal tension. Repair any conditions found. Then reconnect the PCM connectors, any inline connectors, and the related component connectors, making sure everything is fully seated and the locks are fully engaged. Erase the codes, operate the vehicle under the same conditions, and read codes again. If P0521 does not return, the wiring or poor connection problem has been repaired. If it does return after this path is completed, the diagnostic path supports replacing and programming the PCM, followed by verification. Keep verification separate from the testing. After any repair made during this path, clear the code, run the vehicle under the operating conditions for the monitor, and confirm P0521 stays gone. The key takeaway is simple. Do not treat this as just an oil pressure sensor code. Confirm the code, rule out real oil and mechanical problems, prove the sensor response, prove the signal, supply, and ground circuits, then make the final call based on the result. For more diagnostic training, visit stepdiagnostics.com.